Hello everyone. In this video clip, I'm going to go over section 6.4 of our textbook. It's about equations involving the inverse trig function. So basically, there's no new material, no new concept we cover in this section, but just a bunch of examples to help you to understand or get you some experience about solving equation involving the inverse trig function. So let me start with the easiest example and keep moving on. Okay, hopefully it will help you to get some ideas of how to solve for an equation involving trig inverse. So start with the first one. Solve for x. Y equal to cosine of 5x. Oh, sorry. 5 cosine of x. 5 cosine of x. Alright, solve for x. It's easy. Cosine of 5x solvable too, same way. So here, solve for x, of course, it's got to be in terms of y. This is the regular trig function. Y equal to this function in terms of x. And they try to find the inverse of that. That's the thing. In order to have the inverse, we have some condition for x, I think. Cosine 0, x less than pi. So I isolate the cosine of x. I got y over 5 equal to cosine of x. So x is equal to cosine inverse of y over 5. And that's it. Alright, so this is the regular function, so cosine function y in terms of x. Now this is the inverse function x. It's a function in terms of y. That's all. And since previously I write cosine of 5x, so let me show that problem as well. Okay. What if I have y equal to cosine of 5x? So 0 less than or equal to 5x less than or equal to pi means 0 less than or equal to x less than or equal to pi over 5. And this is the condition for you guys to have the inverse. So cosine here already, so 5x is equal to cosine inverse of y. So x is equal to 1/5 of cosine inverse of y. And that's it. This is the problem for cosine of 5x. Okay. Now let's move on to a little bit more difficult exercise. How about, oh, I see one. And let's try this one. Four over three cosine inverse of x over 4 equal to pi. Okay, we see the left hand side we got the inverse cosine function, and right hand side is pi. We try to solve for x, right? So let's try to isolate the cosine inverse on one side. Cosine inverse of x over 4 is equal to 3 over 4 pi. Right? I multiply both sides by 3 over 4. And here, get rid of that fraction. And of course, this inverse means x over 4 is equal to cosine of 3 pi over 4 right here. Okay? And I know that cosine of 3 pi over 4, 3 pi over 4 is right here. Cosine of 3 pi over 4 is negative root 2 over 2. So x is 4 times negative root 2 over 2, which is negative 2 root 2. And we have the answer. Okay. Let's try something a little bit more complicated. I see one, so cosine inverse of x. Let's erase this. Cosine inverse of x equal to, it's number 35, sine inverse of 3 over 5. Sine inverse of 3 over 5. And solve for x. Well, I see cosine inverse right here. Sine inverse 3 over 5 is just a number. So really, x is equal to cosine of sine inverse of 3 over 5. And I claim this is really the right answer. However, I claim that we can actually simplify this answer a bit more and make it look easier, much easier to see. And a little trick, as you see previously, is that whenever you guys see the sine inverse something, do a u sub. Then this equal to u. So make this become cosine of u. So if I let u equal to sine inverse of 3 over 5, then 3 over 5 is equal to sine u. Now you can construct a right triangle, u in here, and you know that sine is opposite over hypotenuse of 3 here, 5 here, so obviously this is 4, using the Pythagorean theorem. Okay? So this is cosine of u, so x is equal to cosine of u. Cosine is adjacent over hypotenuse, so 4 over 5. See? Even though cosine of inverse of cosine of sine over 3 over 5 is the same answer as 4 over 5. But this answer is much easier, much better. Okay? Let's try another one. See one, number 37. Tangent inverse. I see sine inverse of x. Sine inverse of x minus tangent inverse of 1 equal to pi over 4. Alright, I got tangent inverse, I got sine inverse. But tangent inverse of 1 is a very special number. Tangent inverse of 1, what angle make tangent equal to 1? That angle is pi over 4. Okay, so this is, you know that tangents of pi over 4 equal to 1. This means what? Tangent inverse of 1 equal to pi over 4. Okay, so this is what? Sine inverse of x minus pi over 4. Oh, the book gives you negative pi over 4, I'm sorry. This is what? Minus pi over 4 equal to negative pi over 4. Change that for me. Okay, this is negative pi over 4. I copied the question wrong. So sine inverse of x is equal to 0. And what angle makes sine equal to 0? That angle is 0. So x equal to 0. Okay. Try another one. How about number 39? Arc cosine of x plus 2 arc sine of root 3 over 2. Root 3 over 2, that's equal to pi. Alright, I see this is arc cosine means, by the way, cosine inverse. Arc sine means sine inverse. But that root 3 over 2 is a very familiar number. Arc sine of root 3 over 2. What angle makes sine equal to root 3 over 2? Root 3 over 2 is right here, so that's going to be 60 degrees, pi over 3. Okay? So we have arc cosine of x plus 2 times pi over 3 is equal to pi, because sine of pi over 3 is equal to root 3 over 2. So arc sine of root 3 over 2 is equal to pi over 3. And I apply it in here. Okay? So arc cosine of x is equal to pi minus 2 pi over 3, which is equal to pi over 3. And what angle? X equal to cosine of pi over 3. And cosine of pi over 3 is 1/2. Okay. Okay. Let's try one more. Let's choose something that's harder than this. Okay, I see 43. Cosine inverse, right up here. Cosine inverse of x plus tangent inverse of x equal to pi over 2. Now that you see problem, I've got cosine inverse and tangent inverse, and x on both inverse functions. Okay, so you have a choice in here. You can either choose to solve for cosine inverse, or you can solve for tangent inverse, and both ways gonna work. So let's start with cosine inverse. Cosine inverse of x equal to pi over 2 minus tangent inverse of x. Okay, I just simply subtract the tangent inverse on both sides, and now I apply the inverse function for cosines. I got x is equal to cosine of pi over 2 minus tangent inverse of x. All right, we haven't done yet because x in the left. We still have x on the right. Somehow we have to take care of the tangent inverse. And we're going to use the same old trick that I showed you many times already. Let u equal to tangent inverse of x. This is your u right here. So this is cosine of pi over 2 minus u. There are a couple ways to take care of this. If you know that cosine of pi over 2 minus u is just equal to sine of u right away, then use the right triangle that we have, this means u equal to, x equal to tan u, tangent of u right here. Tangent is what? Opposite. So x over 1, x here, 1 here. So this side going to be hypotenuse going to be 1 plus x squared. X equal to tan u. So sine u is opposite over hypotenuse. So it's going to be x over square root of 1 plus x squared. So this is really x over square root of 1 plus x squared. So, all right. So what do we have in here? X is equal to x over square root of 1 plus x squared. Can we solve x from here? Yeah. First of all, x could be equal to 0, right? Well, this is the long one. Huh? X equal to x over square root of 1 plus x squared. That's right, because yep. Now we're gonna solve this x from here. So let me erase this, and we're gonna write. I'm running out of space to write. And here we have to solve this problem. X equal to x over square root of 1 plus x squared. The first solution is x equal to 0. Okay. Plug in 0 works. What if x is not equal to 0? Then I can divide both sides by x, and 1 equal to 1 over square root of 1 plus x squared. That's another word. Square root of 1 plus x squared is equal to 1. Square up both sides. And as you can see right away, 1 plus x squared equal to 1. Well, x still equal to 0. Yeah. So one solution, x equal to 0. And I show you right here, I solve a cosine inverse of x. What if I want to solve for tangent inverse? Let's see what we got. Tangent inverse of x equal to pi over 2 minus cosine inverse of x. Alright? So x equal to tangent of pi over 2 minus cosine inverse of x in here. And same old trick, let u equal to cosine inverse of x. This the one right here is u. So this problem is x equal to tangent of pi over 2 minus u. And you see that tangent of pi over 2 minus u is just cotangent of u. Okay? And I have the right triangle again. U equal to cosine inverse of x means x equal to cosine of u. Alright? So angle u right here. Cosine is adjacent over hypotenuse. So this side is going to be square root of 1 minus x squared. Pythagorean theorem. We have this. Cotangent is adjacent over opposite. So this is equal to x over square root of 1 plus x squared. So it doesn't matter what, you're going to end up with the equation. Solve for x, where x equal to x over square root of 1 minus x squared. Okay? And then this is the way we solve. We have x equal to 0. That's the answer. Okay, let's try last one. Just one more, okay? I just rather pick one. Cosine of cosine of x plus 2 sine of root 3 over 2 is equal to pi over 3. It's something that I think we saw this already. Oh no, it's similar but not the same. Anyway, it's in here. And you know the arc sine of root 3 over 2 is, this is pi over 3 right here, so this is 2 pi over 3 equal to pi over 3 for arc cosine of x. Okay, so arc cosine of x is pi over 3 minus 2 pi over 3 is equal to negative pi over 3. Ah, I see why they got the problem right here. Cosine of x, I mean. Okay? And if you study about the inverse function carefully according to our book, the cosine function, the range is going to be somewhere between 0 to pi. Okay? So we cannot have something negative right here. Cosine of x. Cosine of x got to be somewhere between 0 to pi. And the answer they give you right here is negative pi over 3. So what do you say? No solution. Alright, and actually this is like the hardest one of those side of equation involving inverse trig function already. So hopefully we have a couple of examples. It helps you to learn the material well. As usual, if you have any question, please don't hesitate to ask. I'm here to help you guys to be successful in the course. Thank you for watching, guys. Have a wonderful day.